Hi everyone, welcome to my YouTube channel. We're going to look at the function, define the function, evaluating functions, and composite functions. State whether the following mappings are functions or not. Okay, what is a function in the first place? A function is simply a relationship between two sets, the domain and the range or codomain, in which each element of the domain is mapped to exactly one element of the codomain. That is, an element in the domain has exactly one image, has exactly one output. That is a function. So we have these examples here. Which one do we think is a function? If you have here, okay, the question 1, this is a domain, this is a one-to-one mapping. Each element, 1 is mapped to 2, 2 is mapped to 4, 3 is mapped to 6. You see, each element has exactly one image. So this is a function. Let's look at this one. One element has how many images? One has 1, 2, 3. This is not a function. Not a function. But it's a mapping. Let's look at 3. Each element is mapped to one and only one image. Just the fact that 3 has how many images? 3 is mapped to 1, 3 is mapped to 2. It's not a function. This one, X is mapped to A, Y is mapped to A, Z is mapped to A. This is a function. Why? Because each element in the domain has but one image. Look at it well. Each element is mapped to exactly one. But look at example 2. One element is mapped to 3. One element has 3 images. So in other words, we can define a function as that is a function is a one-to-one mapping or many-to-one mapping. One-to-one mapping or many-to-one mapping. A mapping is simply a relationship between two sets, the domain, the codomain. One-to-one mapping or many-to-one mapping. Not many-to-many and not one-to-many. All right, thank you. That's it. I'd like us to look the next part, evaluating a function or image of a function. To evaluate a function simply means to obtain the value of that function at a given point. And once you have a function, like here for example, this function can also be written as g of x is equal to 5x minus 3. You see, this one is telling you the variable that is changing. The variable that is changing. Where you must substitute, you are substituting by where you are seeing the variable. That is each input. That's what you have. So G2 will be 5 into 2 minus 3, which is 10 minus 3 is 7. You substitute wherever you see the variable x. G2 over 3 will be 5 into 2 over 3 minus 3. That's 5 times 2, 10. 10 over 3 minus 3, which gives us 9. That's, yes, this is 9, which gives us 1 over 3. Okay, because we have here 3, 10, 3, 9, 10 minus. Okay, now we equally have this quadratic function to evaluate f of negative 1. What will it be? This function simply means, how do you read this function? It simply means for any input x, you square it, you multiply it by 2 and add 1 to it. So I'm going to take f of negative 1 to negative 1 squared plus 1. I square it. Negative 1 squared is positive 1 times 2. 2 plus 1, 3. F of 2, 2. I square it plus 1. 2 squared, 4. 4 times 2, 8. 8 plus 1, 9. Is that okay? That's how you evaluate a function. Now, likewise here, we have this rational function. Evaluate f of 1. F of 1. We simply go where we are seeing a variable. We replace the variable by the number. 1 plus 3 divided by 3 into 1 minus 5, which is 1 plus 3, 4, 3 minus 5, negative 2, 4 divided by negative 2, negative 2. F of negative 2, negative 2 plus 3, divided by 3 into negative 2 minus 5. What is negative 2 plus 3? Is 1. 3 times negative 2, negative 6. Negative 6 minus 5, negative 11. So our answer is negative 1 over 11. That is how we evaluate a function. Or, in other words, we say the image of a function. Okay? Now, I would like us to look at composite functions. Composite function simply means you are composing two functions or more, right? You are combining them. In fact, knowing the aspect of evaluating a function is very important here. Let's look at this. F g of x. F g of x. Most often, I say the image, the composite function is the image of a function by another function. Look, see. Now, when you had f of 2, if I have f of 2 here, for example, what am I going to do? I will go there, I will say 2 into 2 minus 3, right? So if I have f of g of x, I will just like replace 2 where I'm seeing x. I will simply say it is g, it is 2g minus 3, and that's all. That's composite function. I've combined, taking the function ahead and replacing it in the function in front, behind. Okay? Take a g, you replace wherever you see x in f, which gives us, now what is g? G is x plus 3. So I say 2 brackets x plus 3 minus 3. When I expand, I have 2x plus 6 minus 3, which is 2x plus 3. The same thing here. G f of x. G f of x. Okay? If you have g f of x, what do? You take f. Let me give another approach. You take g f of x. What is our f? Okay, say 2x minus 3. Now, what is g? G is x plus 3. That is every input that you take, you add 3 to it. X plus 3 means you add 3 to it. So this is my input. The output says that input is x, okay, plus 3. So I have 2x minus 3. I'll replace x by 2x minus 3 plus the 3 that is already there. It gives me 2x because negative 3 plus 3 is 0. Are we together? G h of x. G h of x. What does that mean? I take h, I replace wherever there is x in G. Okay? Or I use any approach. Let's say h is the image. We have 5x minus 2. What is G? What is the function G saying? It says for every input, your output is x plus 3. Okay. Now, I will replace, this will be 3 over 5x minus 2 plus 3, which you can go ahead and simplify in its lowest form, or you leave it that way. Okay? Anyway, let's just simplify. So simplify it here. You're going to have 5x minus 2. 5x minus 2 divided by 5x minus 2 is 1. 1 times 3, 3. Yeah, 5x minus 2 divided by 1 is 5x minus 2 times 3. So 3, we have 5x minus 2, which when you simplify, is going to give us 3 plus 15x minus 6 divided by 5x minus 2, which is, you collect the like terms, 3 minus 6, so we have 15x minus 3 over 5x minus 2. Okay, that said, we have another question here. Hg of x. Hg. What does that mean again? I can say the image of G under H. The image of G under H, right? Okay. Our H is 3 over 5x minus 2. So what are we going to do? Okay, I'll take 3. Where is x? 5x. X is at the denominator. I will substitute G there. 5G minus 2. That is it. I will simply go ahead to substitute the value. We have 3. What is our G? Our G is x plus 3. Okay. So 5 into x plus 3 minus 2, which is simplified to give us, this will be 5x. This 5 times 3, 15. 15 minus 2, 13. 3 over 5x plus 13. Again, we have f of L of x. F. L is, our L is 4x plus 3. So what we can do, f L of x means the image of L by f. Okay. And our f is 2x minus 3. What does that mean? 2x minus 3. Our f is 2x minus 3. If you substitute this L where we see x, it means we are saying 2L minus 3. Okay. Now we'll come. What is our L? Now replace our L is 4x plus 3 over 5. 4x plus 3 over 5. 4x plus 3 over 5 minus 3, which gives us here is 8x plus 6 over 5 minus 3. Okay. All right. That's it. Thank you for watching my video. Subscribe